Okay, hi guys. I'm going to go through number 15 on 10.1c. This is another two-sample z-test for the difference of P1 minus P2. And the reason I'm going to go through this one is this is a good one where it is not doing an experiment. So just talking about those conditions. And I will try to go a little bit slower than I did on the review. I'm still going to go quick because it's a video for you guys where you can slow it down, re-listen, pause to write down any questions that you have. But try to make it a little slower than the review. Who owns iPods? As part of a Pew Internet and American Life projects, researchers surveyed a random sample. So right away you can see we don't have an experiment. We have a random sample of 800 teens and a separate random sample of 400 young adults. Okay, this is going to be N1. I always like to kind of call it out first. Here's my N2. 79% said that they want an iPod. Okay, so now we're going to have to go backwards because 79% said that they had one iPod or MP3 player. I don't think that's supposed to be one. I believe that is supposed to be own an iPod or MP3 player. So this is going to be my P hat of 1 because it's describing my 800 teens. And then for the young adults, it's 67%. So this right here is going to be my P hat of 2. Is there a significant difference between the population proportions? You don't see any word about greater than or less than. State appropriate hypotheses for the significance test to answer this question. Define any parameters that you're going to use. This is the state part. P1. I always like to do what I read first. N1, it's about the teens. So it's the true proportion of teens who own an iPod. P2 then would be the true proportion of teens, of not teens, of adults who own an iPod. In our significance test, we always assume that they are equal. And we try to prove what the question's asking us. Is there a significant difference between the two population proportions? So HA, we would say P1 is not equal to P2. Okay, the state part is done. Now 17A says carry out a significance test at the alpha equals 0.05 level. So now I need to do the plan. I'm going to do that over here just to give myself more room. And I have two populations, and I'm just going to start with R though. It is stated that they're both random samples. So random samples of teens and adults. And what I'll do is I'll put the teens on this side and then the adults on this side, just like we did in our notes. Okay, so now our I, remember we have 3 arrows coming out. We don't have an experiment, so we don't have to worry about what we talked about in the review or what I talked about in notes on Thursday. We're going to do the 10% condition here. So I'm going to take 10 times my sample size for my adults. That's my N2. That's 400. Is less than all adults. And then over here, I believe it was 800. So we're going to say 10 times 800 is less than all teens. And then finally what we just have to say is we have to say teens and adults are independent of each other when it comes to owning the iPod. Okay, so we have the independence condition done. Now we're going to do the normal condition. That's our NP. They give us a P hat, we don't have a P, so we start with P hat of 1, that's 79%. Our N1 is 800. So I'm using these two right here. So I'm going to take 800 times 0.79 is greater than or equal to 10, and then 800 times 1 minus 0.79 is greater than or equal to 10. And then I'm going to do it again for my adults, and that's 67%. And 400. So 400 times 0.67 is greater than or equal to 10, And 400 times 1 minus 0.67 is greater than or equal to 10. Okay, my conditions are complete. Now I need my method. This is a 2-sample z-test for P1 minus P2. All right, let's keep going. We have our state done. We have our plan done. Now we need to have our do done. This one is a little bit annoying because we have to go backwards. Our mu is always 0. Again, remember, we need P pooled, which is x1 plus x2 over n1 plus n2. Well, we know n1 and we know n2. n1 again is 800 and 400. Okay, so I'm going to rewrite that down. 800, but we don't know x1 and x2, so we have to actually figure these out by going backwards. We do know the p hat, so 0.79. Okay, so 79% of the 800 kids own an iPod. So what I'm going to do right now is I'm going to take 800 times 0.79 to give me that x1. 800 times 0.79, and that gives me 632. So nice number there. Round up if it doesn't give you that number. And now we know that 67% of adults own an iPod and of the 400. So I'm going to take 400 times 0.67. So 400 times 0.67, and that gives me 67, which again is a nice number there. And now I'm going to take 67 plus 632. Hold on real quick. I lied, I don't know why. Right away I knew I did that wrong. 400 times 0.67, check that in your calculator with me. And that's going to give you 268. I accidentally put 100 there when I typed it in my calculator. Okay, so we have our x1 and our x2. How did we get that? We went backwards to get those because they didn't give it to us. I'm now going to add my numerator together, 632 plus 268. And that gives me 900 total people in this big pooled together group own an iPod over 1,200. And that's my P pooled right there, guys. Know where the formula is on your formula sheet. Now, if you don't know, ask for help, email me, see me in the morning before the test. I'm going to take 900 over 1,200 times 1 minus 900 over 1,200. All times 1 over n1, which is 800, plus 1 over n2, which is 400. I do not need to calculate that. The calculator will do the work for me. I am now going to go to my graphing calculator and I'm going to run the test. So I'm open it up right here. And I'm going to go to that 2-prop z-test again. 2-prop z-test is number 6 right there. And my x1, we said, I'm going to move it over because I don't have it memorized. My x1 is 632. You cannot put a decimal in there, you guys. 632 over my n1, which was 800. And my x2, I don't have memorized. It's 268 right here out of 400. Okay, so let's put it back up. And now I'm doing a not equals to, so I'm going to hit enter right there. And I'm going to go calculate. And there we go. I'm going to draw the screen over here so we can see it better. I'm going to shrink it so it's not so big. Okay, so what did we find? Well, you can see our difference here. We have our p hat of 1.79 minus our p hat of 2.67, which gives us 0.79 minus 0.67 gives me a difference of 0.12. Okay, where am I going to mark that? I'm going to mark that right here. P hat of 1 minus P hat of 2 gives me a 0.12. I'm going to mark this side, but I'm also going to mark the equal area on this side. Why? Because it's not equal to. Now I need to get my z-score. Z is equal to 0.12 minus 0 divided by the standard deviation, which gives me a z-score of 4.52. Man, there's not enough room. And then finally a p-value of approximately, now because it's e to the -6, anything that's over -5, or -5 or over, we're good to say it's approximately 0. And now I can conclude. And I have no room, I'm guessing you don't either, so I'm just going to conclude right here under B, and we'll move B down, because our p-value is approximately 0, which is less than alpha equals 0.05. We reject the null hypotheses. We have evidence, and I'm going to show you what I'm going to do. You can't do this so easy, but I can, which is kind of nice. Where's my camera? I'm going to take my camera here. Oops, shoot. Oh no, it's not in context. We have evidence that there's a significant difference. I'm not going to write it out, you guys, because I want to try to save time. The longer these videos are, I feel like you don't watch them as much. So we're going to just state, or I could type it. Here we go. We have evidence that there is a significant difference between there's a significant difference between the proportion of teens and adults who own iPods. All right, perfect. Now part B says construct and interpret a 95% confidence interval for the difference in the population proportions. Explain how this confidence interval is consistent with the results in part A. Okay, I'm going to quickly go through that now. Let me take a picture though. Or I'm going to go right to my calculator, you guys. Okay, we're going to go to stat. We're going to go, because all our information should still be in there. We're going to go to tests, and we're going to scroll down to 2 proportion z interval. So we've practically done the state already. With the confidence interval, you don't need the null and the alternative. The plan is the same. The method is going to change to a 2 sample z interval for P1 minus P2. And I'm going to go to that 2 prop z interval. And I believe all my x1, my n1, my x2, my n2 is still okay in there. I'm just going to change it to a 95% confidence interval because my significance level is 5%. And so that's what I need there. And I'm going to calculate. And now what I'm going to do is I'm going to just bring the screen over here. And we're going to talk about it. So now we're talking about part B. So what do you need for part B if I was going to construct an interval? Okay. For part B, to construct the interval, you need the state. We've already talked about the state, P1, P2. I'm not going to take the time to rewrite it. You're going to have to rewind. We stated it up here already. Okay, in blue. The plan is the same. We already went through it. It's stated up here, and you can just write that if that was a part B. Conditions are already met over in green and blue here. Okay, I'll highlight it. Oh. Okay, so here and below, there's my conditions. All right, the method, all it's going to change is this word here. It's not going to be a z-test, it's going to be a z-interval. Again, what am I doing right now? I'm doing part B, and I'm saying construct and interpret a 95% confidence interval for the difference. Okay, so we did the plan, we did the method, now we do the do. Just make sure you know how to do the do for the test. We're going to take p hat of 1, which they give us, 0.79, minus 0.67. It's a 95% confidence interval, so 1.96. Now our standard deviation is different. Don't mess this up, you guys. We don't need a pooled standard deviation. I take 0.79 times 1 minus 0.79 over 800. Look at your formula sheet. You know where this is. It's right by the pooled one. It's right above with a 2 sample. Look at that standard deviation for proportions. And then I'm going to take 0.67 times 1 minus 0.67. Oh, I'm going off the screen. Divided by 400. The calculator does the rest of the work for me. As you can see, we already have it. And my interval goes from 0.06, you know how it says it, 0.06596 to 0.17404. Okay, now how am I going to interpret this? Use the question to help you again. I'm 95% confident that the interval from 0.06596 to 0.17404 contains the true difference in proportion of teens who use iPods versus adults who use or own iPods. Let me state that one more time. I am 95% confident that the interval from 0.06596 to 0.17404 contains the true difference in proportions of teens who own an iPod versus adults who own an iPod. Okay, now part of part B though, look what it says. It does say, explain how the confidence interval is consistent with the results in part A. Why is it consistent? Well, we rejected the null. The null is that P1 is equal to P2. We found evidence that P1 is not equal to P2. We found evidence for HA. How do I know? How is this consistent? Our 95% confidence interval does not include 0. If it included 0 in here, that means there's a chance they're the same, but it doesn't include 0. So we have evidence that there is a difference between them. How big a difference? Anywhere from 6 to 17% approximately. All right, I'm signing off. I hope this helped. Everyone have a great day off tomorrow and happy studying.